Yes, good evening, everyone. We'll be starting a new topic that is purifier from today. So, what is the need of purification, or what we are actually achieving by doing this purification? So, we understand that the centrifugal filters, the centrifugal purifiers that we are using on board, they are used to separate the liquids, okay, which are having different densities, like water and your oil. Some oil will be containing some water content, and that water content we need to remove. Also, some there will be some sludge and your solid particles in the oil that we have to separate. So that is all what is done in your centrifugal purifiers that is there on board the ship. Now you can see here the separation process of the two liquids with different specific gravities, because water will have different specific gravity and the oil will have different specific gravity. For example, I have a container in which I have a mixture of water and oil. Okay. So what will happen after some time, if I'll keep it in this state only, the oil particles will rise up and water particles will be accumulating on the bottom side by itself. Okay. That is by the gravitational force itself, these particles will be settling down, the heavier particles, which is the water. Why? Water has higher density than oil. That is why the oil will float and the water will settle down. Okay. Also, if there is sludge in the oil, that sludge or any solid particles will be accumulating at the bottom of the container. At the bottom, it will be accumulating the sludge part, because sludge has higher density than the water, and water has higher density than the oil. Okay, so oil will always float on top. After that, water will come, and after that, yeah, sludge will be accumulating at the bottom. So purifiers, what is working on this principle itself, that they are used to separate the liquids with different specific gravities. Okay. Now, why we need this purification actually on board the ship? We know that the oil that we are getting, HFO, heavy fuel oil, and all, so they are very dirty oil. Okay, they have a lot of water content into it. A lot of solid debris are there inside it. Okay, a lot of cat fins are there in it. So purifiers will remove all those parts and make the oil, in a cleaner state, so that this damage does not happen to the components of the engine. Now let us say if we are not giving this purification system, then the water, when it goes to from your fuel oil, okay, suppose from the fuel oil the water is going, or you can say the lube oil system, okay, lube oil purifiers also we have on board. So the water content can damage my liner. It can lead to corrosion of the liner. It will also damage my piston and piston rings, right? Piston and piston rings might get damaged if this water is allowed, or if the sludge is allowed to go inside through my injectors and my pump. Okay, so these can get damaged. Even my fuel injector and my fuel pump components are going to get damaged if I don't purify the oil. Okay, so that is why it is very important to do the purification process and to remove the water content and the solid contents from the liquid. Now, if we talk about this methods of separation, so the first method of separation is of gravity separation. That gravity separation is happening in our gravitational separation is happening in on board our ship in the tanks, right? Like your bunker tanks, okay, in your settling tank, in your service tanks. So there, the gravity separation is taking place. Now, what happens is, suppose I have a tank, okay, which is filled with oil. Okay, this tank is completely filled with oil. For example, it is a settling tank, suppose. Okay, fuel oil settling tank. And whatever the molecules of, water, suppose I have one molecule of water content into it, for example. So this water molecule is obviously is higher density than the oil. I discussed that the density of water will be higher as compared to density of oil. Normally the density of water is 1. Okay, and oil density will be always less than 1. For example, I'll take an example of 0.95. Okay, so what will happen? This water particle will slowly starts to go down. Okay, and finally it will reach at the bottom and it will accumulate at the bottom. So all the water is and your solid particles will start to accumulate in the bottom, and this is known as the gravity separation. Okay, now you can see over here I have drawn a diagram how the system is. Okay, a very rough diagram. I have a two starboard bunker tank. From there, okay, it also have a heating coil. Okay. Now, how much minimum heating I have to supply in bunker tank, that depends upon the pour point of the fuel oil. Okay. If the pour point of the fuel is suppose 20 degrees Celsius, then I need to at least keep this tank temperature or heated up at least more than this temperature. Otherwise, your transfer pump will might not take suction if the temperature drops below the pour point. Okay, so always maintain temperature of bunker tank according to the pour point and should always be higher than the pour point of the oil that you are using in the bunker tank. Okay. From there, I have a filter and then I have a transfer pump. The transfer pump is transferring this oil to the fuel oil settling tank. Now, fuel oil settling tank, I have, if you see in the diagram, I have on the bottom end part, I have drawn in a little bit angle the tank construction. Okay, that is to facilitate if this tank construction suppose is like this. So what will happen this tank? Okay, suppose this is in a settling tank. So what will happen? Whatever water is and your sludge is getting accumulated, it will accumulate at the bottom. And from the bottom side, I'm going to make a drain wall. Okay, and I'm going to drain this water and my uh, solid contents. Okay, so normally we are doing it in every watch. Okay, settling and service tank drains, we are doing it every watch to remove whatever the water and your solid contents are present in your settling and service tank. Very important step to drain the tanks regularly. Otherwise, there will be a time that only water is going to flow through your purifier, and that is not what we want. Okay. Now, the next step from the settling tank, it is going to another filter and then to the purifier feed pump. Okay, purifier feed pump. After purifier feed pump, you will be having a heater. Okay, a steam heater is there which will increase the temperature of the fuel to the inlet of the purifier. Okay. Normally, the temperature at the inlet of the purifier is about 95 to 98 degrees Celsius, and that is the job of heater to maintain it. Okay. We will see later on why this heater is so important. Okay. Why I'm increasing the temperature. We will see. So after that, it will be going to the purifier. Purifier will remove the water content and your what you say solid particles. Okay, and it will allow only clean oil to go further, and which oil this oil will be getting accumulated in your service tank. Okay, there also will be having heating coil. Okay, there also will be having heating coil, and there also gravitational separation is happening, and you're draining out whatever water content is still left after the purification system. So I think this much is clear to everyone now how the system is working. Now, if you talk about the force that is acting on this water molecule, what force is acting that it is, separating it out from your oil. Okay, that force is known as separation force or separating force. Okay, so a separating force, there's a formula for it, that is pi by 6 dq, density of water minus density of uh, oil into gravitational force. That is what is happening in the uh, in case of gravitational separation. Okay, that is in your bunker tanks and your service tank and your settling tanks. Okay, so this is the formula. In case of purifiers, when the separation force is, in case of purifier, this separation gravitational force, which is over here, is replaced by centrifugal force, that is r omega square. Okay, in case of purifier. But right now, what we are discussing is your gra gravitational separation. So right now, it will be gravity force, what will be acting on that water molecule. So separation force is pi by 6 dq, that d is the diameter of the water droplet, okay, and density difference. Okay, this density difference is very important. The density of water minus the density of oil multiplied by specific gravity. Now I told you, like, suppose I take a water density of 1, okay, water density is 1, oil density I took, suppose, zero point 0.9, okay, it ranges about 0.85 to 0.98 or something, okay, the oil density change according to the bunkers that you're getting received, okay, so you have to check it out in your BDNs and all, what is my specific gravity of the oil. Now, I discussed why I needed a heater, because if I'm heating the oil, I can increase the amount of this difference. Okay, if I increase the difference between the density of my water and my oil, my separating force will be higher. This separating force will be higher, and that is what I want. I cannot change the gravitational force because that is a constant terms. Diameter of water droplet is not in my hand, okay, and it will be very small diameter of water droplet, so it will not increase separation force that much. Only thing that what I had right I am having right now is the density difference. I can create much better. Okay, how I can create right now? You can see only the density difference is 0.01, right? But if I'm going to heat it up, you can see is a specific gravity versus temperature curve. Okay, what I'm going to draw over here. And this is density 1 of my water. Zero point 0.9 I've taken for oil. Okay, oil density, specific gravity 0.9. And this is 1 for water. And this temperature is at 0 degrees Celsius. Okay, or you can say at 15 degrees Celsius. So once I start heating, you can see that the density of specific gravity of the oil drops sharply. Okay, but the water density does not stop. So at higher temperature, suppose if I'm going to maintain 80 to 85 degrees Celsius of temperature in my heater, okay, or you can say about 90, 95 degrees Celsius from the heater, then the difference between the density is going to increase. And this is what I want. If the difference between the density of water and oil is going to increase, my separation force will be much good. This separating force will be much better. And that is what I want. That is why we are heating this oil. Okay, because to increase the separating force, what is acting over there in a purifier. Okay, and obviously the gravitational force is replaced by the centrifugal force, that is R omega square. Okay. Now, if I take an example, one more thing, suppose I have a container in which I have kept oil. Okay. I have kept some oil, and in that oil, some water molecule is present. So after, few hours or so, what will happen is oil will accumulate on the top. Okay. Water will accumulate at the bottom. And at the extreme bottom, you will be having some particles of sludge. Okay. Sludge. And I can drain out this and all from the, if I make a drain valve over here, I can drain some amount of impurities, but still there could be some chances that some water molecules are still entrapped in the oil, and that process we can exaggerate by adding a heating coil into it. But if I'm going to, suppose I'm going to supply a centrifugal force to this container, and if I rotate it, okay, at a high RPM, so what will starts to happen is my oil, okay, or the sludge will starts to accumulate at the periphery, okay, at the very end. This is green color shaded region will be your sludge on both the side. This concept will be helpful when we'll study the purifier part. So sludge will be accumulating over the edges. Okay. After that, the density of water is there, right? Then the water will accumulate over here. And finally, in the inert part, you will be having the clean oil. Okay. Now you understand when the centrifugal force is applied, the heavier particles are pushed outwards. So my density of density of sludge is greater than density of water is greater than density of oil. And this in this same sequence, my you know components are making the interface. My sludge will be pushed outwards because it is a heavier particle due to centrifugal force. When the centrifugal force act and you're rotating this drum or something, tank or something in a high RPM. So because of the centrifugal force, this sludge and the water particles having higher densities will be thrown outward, and the clean oil will remain in the internal part of your purifier. Okay. Then we'll go for the centrifugal purifiers, and in that, now I have replaced my gravitational force by r omega square. Okay, radius is for the half of the purifier bowl, and omega square is obviously the angular velocity that is you're achieving by rotating your purifier bowl. Here, my separation efficiency will depend upon on what all factors. Obviously, my diameter of the water droplet, my density difference between my water and my oil that I can increase by heating up my oil. Okay, the separating separation efficiency will depend upon, first of all, the separating force. Okay, whatever we have discussed in this separating force part. Okay, that is diameter of the water droplet and the density difference, and obviously my angular velocity. Okay, the more RPM you give it, the better separation force it will provide me, right? Then time also is a factor. Okay, time will also decide how much separations is happening inside my purifier. And finally, the viscosity of the oil. Okay, so if I increase the temperature, the viscosity drops. If the temperature of the fuel oil inlet, what is we are feeding into the purifier, is dropping, then the viscosity will increase. And if the viscosity increases of the oil, suppose I have oil, okay, I have some oil over here, and this is suppose a water molecule over here. And if the temperature is less of this oil, this water molecule, when it is coming downward, will will have to uh, come across your drag forces of the oil. If the temperature is less, okay, it will feel that drag force, okay, and separation will not be very good. Okay, so we have to maintain a certain temperature in order to decrease the viscosity, okay, so that the separating force can be better. Okay, suppose if the viscosity is higher, I have written over here, okay, then the separation will be poor and vice versa. Okay, so if the viscosity is low, that means the temperature is higher, and that time my separation will be good. All right, so we move forward and we'll come over here. So this is okay. Let us see the parts of a purifier one more time. These are the parts, okay, the internal parts. We'll right now only see the top part in the bowl, what is there, and later on we'll see when we'll study about your vertical shaft and all. We'll see the all the vertical shaft components and the horizontal shaft components. So this is my lock nut. This is my gravity disc. Okay. So gravity disc is mounted on the water side of your purifier. Okay, it maintains the interface. Then I have O-ring. Then this is my light liquid chamber. Again, one O-ring. This is my centrifugal pump. Sometimes surveyors do ask, where is the place in engine room where we're using centrifugal pump? So it is a purifier where we are using the centrifugal pump. This is the inlet shaft. This is the ball knocking nut. And this is my, so this is the bowl hood, main sealing ring, one and it is main sealing ring. Okay. This is my top disc. Okay. You can see in top disc, there is no hole. It is without holes. Then I have the separating discs. All my discs are there. Okay. This is my disc stack and all. Okay. These are going into your distributor. Once it is a distributor, this is a locking thing which is going to lock it onto your bowl. Okay. This is 105 is your sliding bowl. And these are some, step from sorry, O-rings and all. And then the main bowl. Okay. This is the lock nut, which is keeping all the components together with your vertical shaft. Okay. So this bowl has to be, main bowl has to be attached to your vertical shaft, and that is done by this lock nut. So these are the parts inside the purifier. Okay. Now if I come over here and I'll show you the parts in this thing. This is my back pressure. So this is the place from where my oil inlet happens. That is my dirty oil is going to come into it. Okay. After your settling tank, when it comes from the heater, it is going from the center of my uh, purifier from the distributor. It is going inside and is getting fed into my distributor, and it will be going upward from these holes in the disc stacks. Okay. You can see on the discs, I have a very slight hole. Okay. These holes are present on the disc stack. Okay. And from these holes from the bottom, the oil will be coming up. So oil will be going up like this. Okay. Oil will be going up like this. And whatever the molecules which are heavier will be pushed outwards. Okay. Like water and sludge. You can see it over here. This red color part is my sludge, and the blue color part is my water. So it will be pushed outward, separating out the water content and the moisture, your solid content from the dirty liquid. And finally, what we will achieve is a clean oil that will be going inward, and it will be coming out from the clean oil outlet. Okay. This is my clean oil outlet from where my clean oil will be coming. Okay. It will be going like this, but some amount of dirty oil will be remaining here. Okay. Here, purification is still happening and all. It will also become clean, and it will go inward, and it will finally go out from the clean oil outlet, which is this one. Okay, there's a back pressure valve. Normally, the back pressure what we maintain according to different purifiers, it is a different value, but in the normal range of 1.5 to 2.2 bar pressure, we have to maintain. This is my pressure gauge, suppose. Okay, so this much pressure we are maintaining into my purifier, because I don't want a purifier to act as a pump, right? I want certain back pressure always to be created back into my purifier, so that oil can remain for a some time, because we saw that separation efficiency will also depend upon time, right? So I have to give certain times into my purifier so that my oil can stay in my purifier for some time, so that purification can happen. The centrifugal force might will act upon these solid particles and my water molecules to separate it out. So I have to give some back pressure to my oil, otherwise it is just acting like a pump, isn't it? All right. Just erase this part. Now we will talk about certain things about the interface. Okay. So the interface, where we are maintaining the interface. Ideally, the interface should be, if this is my top disk. I told you top disk is without holes. Okay. This is the top disk. And the remaining part, which is over here, this is my edge of the disk stack, right? This is the edge of the disk stack. So I want my interface to be in between, it should not be coming inward to my disk stack. It should be outward from my disk stack. But it should not go out from my top disk. Okay. It should be in between these two things, between the edges of my disk stack and my edge of the top disk. So you can see the interface is becoming over here. What is this interface? So if I take a simple example, if suppose I've kept a mixture of oil and water for a long period of time, what will happen after some time? Water will accumulate at the bottom, and oil will accumulate at the top. So this line will known as the interface where this separation is happened over here. So in this purifier, we want ideally this interface to form. This is my interface. This is the interface. Okay, this is interface. This interface line should form within the top disk, but not on the what do you say, the disk stack. Okay, it should not on the edges of the disk stack. So it should be in between. Okay. Now a lot of factors will affect this interface. Okay, that we will discuss after some time. Okay, so this is the place where the interface is forming. When the oil will come, okay, here that I've already discussed, when the oil is going to come over here and it will enter from here, whatever solid or your liquid particles, okay, it will be expelled outwards because of the centrifugal force. It will be expelled outwards, okay, and it will be accumulating onto your interface, okay, and the solid particles obviously will go towards your periphery. This is my solids, right? So this from here, some amount of water is allowed to leak out, and it will leak out from the water outlet, okay, which will go to your sludge tank, okay. And you can see on the water side only I have this gravity disk mounted. Now, the purpose of gravity disk is to maintain the, you know, interface in the purifier, right? Now suppose if I'm going to, you know, change the diameters of my gravity disk, how it is going to affect my system and all. Before that, I will discuss about something else, that is a balanced equation and how it is, what it is. Okay. So if I take, this one, a center line from here, okay, this will become my center line of the purifier. And this is clean oil outlet line. This is the clean oil outlet line. And from the edge of my, this, what do you say, gravity disk, is one more line. That is my water outlet line. Okay. So the distance from the center to the water outlet line, this distance is known as H. Then the distance from the oil outlet to the center line is known as L. And finally, the distance from the center of these holes in your discs that you are having, okay, from there to the center line of the purifier, that is known as E. This is known as E. So there is a derivation actually. We don't have to go to the derivation. We just have to remember what is my balance equation. And this is what it is. Okay. This balance equation is what we are getting derived out of this. And this equation, until it is balanced, your purifier is not overflowing, at least because of the density of the oils factor. Okay. So this is the balance equation that we are getting. That is rho of water, that is density of water, E square minus H square, okay, equals to density of water, oil, E square minus L square. Okay. Now, suppose if a supplier has given you oil in which the density of oil is higher. For example, the last bunker that you're having and you were using a density of oil as 0.9. Okay, 0.9 was the density of oil that you were using HFO. Now you get a new bunker in which the density of oil has increased to 0.98. So what you're going to do in the purifier? So if you see, if my density has increased, if this value has increased here, Okay, density of oil has increased. So that means now my balance equation is not balanced. My RHS side will increase than my LHS side. Now, in order to increase also LHS, I have to do something. I have to increase something in my LHS. Okay. Now, density of oil or density of the water is constant. I cannot change it. This E distance is also constant. This is the distance between the center line and my center of the holes in my purifier disk. I cannot change it. The only thing that I can change is the H. Is this H? This I can change. This is H square. Huh? E square minus S square. So this H I can change. What is this H? It is the distance from the gravity disk. Okay. This distance. It is a distance from the gravity disk to the center line. If I can change the size of the gravity disk, I can change the H value. Okay. So what I will do is, you can see over here. If the density of oil increases, okay, in order to balance this equation, H has to be reduced. If I suppose this is density of water, if I have to increase this value, I have to reduce this H. If I am able to reduce the H, this value will go up and it will match with the my RHS value, okay, right hand side value. Okay, so this H has to be reduced. How I can reduce the H? By changing the gravity disk, and hence the diameter of the gravity disk needs to be reduced, and vice versa also. If density of oil has reduced, then you have to change the gravity disk in vice versa situation. Okay, so I have to reduce this H value in order to make this complete value a little bit more, so that it equals out my right hand side value. And that difference has come because of the change in the density of the oil in the bunker that we have received. So that means I have to, if the density of oil has increased, I have to decrease the size of the gravity disk. Okay. Now, if I decrease the size of the gravity disk, that means internal diameter. Okay, so this is my gravity disk. That means this internal diameter I have to reduce of the gravity disk. You can see the gravity disk is this one, right? So this is my internal diameter. So if I reduce the diameter, outer diameters of all gravity disks will remain same. The internal diameter only changes of the different gravity disk, and you will be supplied by the manufacturers a lot of sizes of the gravity disk. So what you're going to do is, you have to use a gravity disk which whose internal dia is lesser as compared to right now what you're using. So this is my internal dia. So when this internal dia is less, then if I erase all this part, okay, then I'll just erase all this part. That means it will be extended a little bit further. Okay, the gravity disk part will extend a little bit further. That is why my internal diameter is becoming shorter. And now my H value is also becoming shorter. Previously it was greater. Now the H value will be this much. Okay. So I have reduced the H. Once I have reduced the H, my this value becomes greater. Okay. Or it increases and it matches your value of this right hand side. Okay. So if surveyor asks you about if density of oil has been changed or it is increased, density oil, what you got in the bunker has, it is more than the previous density, what is going to do in the purifier? Then you have to say that I will use a gravity disk with smaller internal diameter. Okay, this is what you have to say, and this is also vice versa. Also, if he says you, if the diameter has or your density has decreased, then you have to use a bigger diameter of the gravity disk, internal diameter. I hope this is understood. All right. So a lot of factors will, give you like this about this interface part. A lot of factors are there on which this interface will depend upon. Okay, and that is what we are going to understand now. Okay, I hope this is understood. All right.
एक्सप्लेन करिए सर.
I'm speaking English only, right? What part you did not understand?
हाँ सर.
कहीं पे if I've used somewhere Hindi, then please tell me what is the thing that I have not you have not understood.
No, sir. Can you hear me, sir?
Yeah, yeah. Tell me.
Sir, I understand, but sometimes we speak in Hindi and don't know
Yeah,
what we speak.
natural.
That's the
Okay,
problem.
no
I
problem.
just
I
want to
will
know.
try. I will try. Okay, if I'm
Okay, okay,
speaking, then you please tell me. Yeah, okay. It is pretty
okay,
natural for us to sometimes
okay.
switch. Take it. Okay. So this is the distances are clear to everyone.
Yes, sir.
With this distance, another there is one more derivation that we are not going to do it. Okay. But with that derivation, what we are getting is a balanced equation. Okay. That you should remember that will help you to answer few questions. Okay. That is density of water bracket E square minus H square omega square equals to density of oil E square minus L square omega square. Omega square will cancel out. And what you will be left with is density of water E square minus H square and density of oil E square minus L square. Okay. I started recording, right?
नहीं, हाँ सर, चल रहा है.
Okay. So you can see H is from the water side, right? So I've taken it on the water side. Okay. So there's a complete derivation
Yes.
actually for it, but I don't want to go into derivation part. Nobody's asking you that. This is a balanced equation. Until this is balanced, your purifier is not overflowing. Okay. So sometimes people are asking questions like, what you will do if the density of oil is going to increase? Okay. Oil density increase ho gaya. If you have taken the bunker, okay, and the oil density is more, suppose the previous oil that you were using in bunker that was 0.9. Now you are using another bunker you have taken. Its density is 0.98. What are you going to do? People are asking like this question in the interview, isn't it?
Yes,
So
sir.
we will, yes, sir.
We will run the
If
purifier as a
if
clarifier in that case.
no no no,
So we will change the
purifier
gravity
will
disk
be
as,
changed. Wait. Purifier will be changed to clarifier in one state if it is density is going above one. Okay.
Number one, okay.
If the
Rest,
oil
we'll
density
change the
is
gravity disk only.
yes, if the oil density is going above one, then in that case you should run those purifiers into clarifier mode. Clear? Always remember that. Okay. I have discussed it with one of my students who days back only that in previous shift it had happened to me and my fourth year overall all four purifiers all were overflowing and he did not even check what is the density of the oil. Okay, you should never overall all the purifiers together and everything is open and he's coming to me, sir, all purifiers are overhauling, and I said if all are overhauling it is a common problem, you should not have overhauled it. I saw the density is more than one. It is written in the manuals also, if the density is more than one, go for a clarification mode. Okay, don't use it as a purifier. So if the density is more than one, you use it as a clarifier. But if it is, suppose from zero point 0.9 it has increased to 0.98. Okay, so my oil density has increased.
Yes, sir.
Suppose this is my LHS side, left hand side, and this is my right hand side. So
हाँ सर.
now the balance equation has been interrupted. My RHS has increased, isn't it? My
Yes, sir.
density of water is constant.
Yes, sir.
The distance from the center to the holes of the discs is constant.
Yes, sir.
But this H, can I vary it? Can I
yes, sir,
change my
size of gravity,
gravity
yes,
disk
sir.
size? Gravity disk का
Yes,
size
sir.
change कर सकता हूँ.
Yes, sir. हाँ सर, हाँ
Okay.
सर.
So if my LHS has increased, what I need to do for sorry, RHS has increased. What I have to do for LHS also I have to increase.
Yes, sir.
Yeah, you agree? So in
Yes, sir.
order to balance the equation, I have to increase the H or decrease the H.
We have to decrease the H.
We have to decrease the
Increase.
H. Yeah, increase करेंगे then the difference will come more ना, e square minus h square, and it will further go down. So we have to decrease the h, isn't it?
Yes, sir.
Right? Hence the diameter of specific gravity disk needs to be reduced. ठीक है? Is it clear? This diameter of the this thing has to be reduced. ठीक है? h को increase करना है. Suppose,
Right.
wait. This h has to be reduced, right? That's why this e square minus h square will be reduced. Agreed? And if it
हाँ
is
सर,
reducing,
अग्रीड
then
सर.
my LHS will go up. Agreed? In order to reduce this h, I have to change my gravity disk. I'll write it over here. If
सर बट
Yes,
आरएचएस
sir.
अगर बढ़ गया है, डेंसिटी बढ़ गया है, तो इधर भी तो डेंसिटी बढ़ानी पड़ेगी ना, तभी मैच कर पाएंगे ना सर.
where you have to increase density, ऑयल का डेंसिटी इंक्रीज हुआ ना.
हाँ, ऑयल का बढ़ गया सर, तो अभी फिर ये वाटर तो कांस्टेंट है, ई भी
Yes,
कांस्टेंट रहेगा सर.
correct. Only h is variable. That is the distance from your
सही
gravity
सर.
disk to your this thing,
ग्रेविटी
right?
टेक्स टू सेंटर.
The density of oil increases in order to balance the equation. H has to be reduced. Agreed? This much mathematics.
Yes, sir.
Hence,
Is there any particular name of this equation?
normally it is known as balance equation only. ठीक है? और कुछ होगा तो मैं एक बार देखता हूँ न्यूमेरिकल पार्ट. ठीक है?
Okay, sir.
Let's reduce the diameter. I don't even remember now. Okay, I'll check it. ठीक है?
Okay, sir.
So, in order to balance the equation, H has to be reduced. Hence, diameter of what do you say, gravity disk needs to be reduced. Okay, and vice versa. Okay, according to the oil, we will see later on how we are selecting the gravity disk. There is a nomogram method. Okay, which you should all follow. We will see that in later classes. So, is it clear this much?
यस सर.
Tell me. Okay, is it clear? All right. Now,
मतलब डायमीटर घटाना पड़ेगा ना.
yes. Okay, hold on. अगर मैं diameter is going to reduce, suppose इतना कर लिया, my h is decreasing. Now this will be h. Agreed? Before it was this much.
हाँ सर.
Agreed?
हाँ सर.
Understood? ठीक.
तो डायमीटर बढ़ाया है ना सर इसमें तो.
बढ़ाया कहाँ? Diameter तो कम हो गया ना. It is reduced ना. See, this is one diameter. Okay, complete diameter. Agreed?
ओ, अच्छा, ओके सर, ओके, समझ गया. तो मतलब दोनों साइड जब बढ़ा तो अप्रोक्स पूरा डायमीटर कम हो गया, आप ऐसा बोल रहे हैं ना
Reduced
सर.
हो गया, right? Okay, understood ना सबको? See, this is the gravity disk at this moment. If I am going to reduce the diameter, that means ये increase हो जाएगा and diameter will reduce. Agreed?
समझ गया
Complete
सर.
diameter. So radius भी तो reduce
यस
हो
सर.
गया, right? The h value. Okay.
हाँ सर.
Right.
सर मतलब डायमीटर घटाएंगे तो सेंटर से उसका डिस्टेंस कम हो जाएगा ना.
Obviously ना, देखो एक इस ये है आपका gravity disk, ठीक है? This is my diameter.
जी.
Agreed? Now
हाँ
if I
जी.
reduce the
हाँ जी.
diameter, तो मेरा h भी तो reduce हो जाएगा. Agreed or not? Center से यहाँ तक h
हाँ जी.
होता
हाँ
है,
जी.
right?
हाँ
That is
जी.
what I
हाँ
wanted.
जी.
Agreed?
हाँ जी.
Okay. So let us take few example of your अभी gravity disk की maintain कर रहे हैं तो so gravity disk first of all you understood the location, it is always on the water side, right?
Water
And
side.
it maintains the what is the purpose of gravity disk?
To
It maintains the
maintain the
interface.
interference.
Interface.
Interface.
Interface को maintain करना is the purpose of the gravity disk is to maintain the interface. Now this is the oil from where it is entering into the system. Okay, oil is entering into the system. It is going down from the distributor. Is it the distributor?
Yes, sir.
Yeah, distributor say it is going down. Then it is going to come up from these holes of the discs.
Yes,
Agreed?
sir.
Now at this point, the heavier particles will be pushed outward.
Yes, sir.
Centrifugal force. It is rotating. Okay, it is rotating at 8,000 RPM. So because
Yes, sir.
the heavier particles are pushed outward during the centrifugal force, isn't it?
Yes, sir.
Okay, and the clean oil will be going from here, return back. This is the place where my centripetal pump is, there. This is the place where centripetal pump will be there. Okay, we'll see in the other diagrams. Okay, so this is the place where centripetal
Yes,
pump
sir.
will come. Okay, so now this is the play. My interface, where should be the interface? The interface should always be inside my top disk. This is my top disk.
Yes, sir.
It should be inside, but outside the disk stack.
Distance.
This
Disk stack.
Okay. So it can I say it is in between my top disk and my disk stack, edge of the
Yes,
yes,
sir.
disk
sir.
stack. Okay. If it is this is the point where we have to maintain the what do you
Interface.
say interface. Okay. Is it understood till now?
मतलब सर
Anyone anyone who is not able to understand? Tell me
below the
anyone.
top disk and
This
The
is
last
my
one, can you explain again?
this is my top disk, right?
top
Agreed.
disk.
Top disk does not
Yes, sir.
have any holes. Okay. This is
Yes, sir.
my complete disk stack, and this is the edge of the disk stack. Agreed.
Yes, sir. Yes, sir.
Oil is entering from the holes of the
Disk stack.
discs. Okay. And it is going like this. And whatever the heavier particles will be there, that will be pushed outward.
Towards the periphery. Yes, sir.
Okay. Like water and your sludge will be pushed outward. And the clean oil will be going towards inward. Agreed?
Yes, sir.
Okay. Now, when this is pushed outward, you will be having an interface between the oil and water. This
Yes, sir.
complete part will be filled with oil. Okay. यहाँ पे पूरा oil रहेगा. Okay. And
Yes,
this
sir.
is blue color is water. So this is my interface.
Yes,
Agreed?
sir.
Okay.
Yes,
So
sir.
I want my interface to be always inside my top disk, but outside my disk stack edges. Is it clear? You can see the
Yes, sir.
in this diagram also. This is the point where my what do you say interface is there. Agreed?
Yes, sir. Yes, sir.
Okay. Now I told you that gravity disk is maintaining the interface, right?
Yes, sir.
Agreed. Suppose if I increase the size of gravity disk. Case one I will take. Can I erase all this जो I have written over here?
Yes, sir.
Yeah, okay.
Yes.
I will explain with the diagram itself ना तो आपको ज़्यादा अच्छा से समझ आएगा. Okay. So case one. Gravity disk size is increased. Suppose. Okay. That means too large.
The interface will go outwards.
Yes. So if I'm putting too large, that means the diameter is large, right? The diameter I
Yes, sir.
have increased. So if the diameter I have increased, can I say only this much is my gravity disk? बोलो पहले से.
Yes. Yes, sir.
ठीक है.
Now my water can easily go out. If water is going out, ठीक है, बाहर जा रहा है, निकल रहा है, okay, the water is going out, will this interface push towards outward?
Yes, sir.
Yes, sir.
Tail ही बनेगा.
This is my top disk. Okay, this is where the interface was forming. Okay, now if water is easily going out from the water outlet, okay, because you have a bigger gravity disk, so the interface will start shifting na, धीरे धीरे. This interface will
Yes, sir.
start shifting towards outward, and there will be a time when it will be outside your top disk interface. Agreed? Guys, bolo, is it understood? Guys, am I audible or net connection फिर गया मेरा?
Yes, sir.
Yeah. Okay. So what I was saying, if water is easily getting out of my purifier because I've used a bigger gravity disk, doesn't that mean that the interface is also shifting outward? It is
Yes, sir.
going towards the periphery. Agreed? So if it is going, don't you think the oil which is there, it will start overflowing from the water side?
Yes, sir.
Sometimes they ask you, oil is coming from the water side. Okay. So one of the reason could be the gravity disk. Agreed?
Yes, sir.
Yes, sir.
Okay. So this is the case 1. Okay. Now case 2. Suppose gravity disk size is decreased. Right? Too small. Small means it will go like this. Diameter is decreasing.
Diameter बढ़ जाएगा. Yes, sir.
Decreasing. Huh? Diameter is decreasing.
हाँ sir.
Right?
हाँ जी, हाँ जी.
So what will happen to my interface now? Where it will be pushed?
Sir.
It will push inwards.
Inwards.
Okay. It will come obviously towards till here.
Yes, sir.
Agreed. And if it comes
sir.
inward, there are chances that the water may go with your clean oil. Water content बढ़ जाएगा.
Yes, sir.
And
Yes,
your
sir.
sensors are mounted on the outlet side, right? Water transducers are there. Okay. Which are
Yes, sir.
sensing your water content in the oil.
Water content, oil.
Right. So it will give an alarm and it will give a command to purify to desludge also. Okay. So is it understood what is happening if I changing the gravity disk and all, and how my interface is
Yes,
getting
sir.
affected by it? Okay.
Yes, sir.
So gravity disk purpose is to maintain the interface, and you know now where the interface is made. Agreed? Follow? Is this much understood?
Yes, sir.
Okay. What
Yes,
all
sir.
other factors that are going to affect your interface? What all the other factors are there? Suppose I told you there is a back pressure valve over here, right?
Back pressure.
Right?
Yes.
Back pressure valve. If I'm going to close this valve, then my oil cannot go as much as before it was going.
Yes, sir.
If I'm going to shut my valve and slightly open, that means it is creating back pressure on the system, right? So my oil will push
Yes,
the
sir.
interface where?
Outside.
Outwards.
Outwards. And there are chances that oil will go from your water side. Again, your overflow. Agreed?
Yes, sir.
Okay. If suppose everything was okay, it was running like this in this state, you are maintaining back pressure about कितना back pressure maintain करते हैं? This is the range.
From 1.5 to
0.8.
2.
This is the range
1.5
normally
to
what I've
2.5.
seen till now. ठीक है? इस range पे we are varying, depends upon purifier also. ठीक है? Depends upon the feed also. Depends how much you know want to have better cleaning and all. ठीक है? So more the back pressure, more the cleaning will be better, but you have to simultaneously reduce the throughput also. Okay. So this is the throughput where the oil is coming in.
Yes, sir.
Okay. Now what if I reduce the suppose you are maintaining 1.5 bar pressure. Okay. Everything was going very good, and you now, or suppose the suction filters have choked, your purifier suction filter, and the throughput has reduced, or you have manually reduced the throughput. Okay, एक bypass valve रहता है, you are adjusting that bypass valve to change the feed inlet. Are you doing it? Has anyone seen a fourth engineer doing back pressure bypass
Yes, sir.
valve
Yes, sir.
adjustment? So
Bypass valve.
he is adjusting a feed actually. Okay. So how much fuel oil I am putting inside my purifier, that will also affect my interface. Suppose now everything was going good and this was my interface. It is exactly at this point. Now I reduce the quantity of fuel. What is going to happen?
Oil will come out from water side.
Inter-
Yes,
interface will go inward, sir.
interface will shift inward. Agreed. Now, if the less pressure is coming, if less amount of oil is coming, this pressure will also fall down. Do you agree? Before 1.5 bar pressure was the back pressure. Okay. Now, if the inlet oil is reduced, do you think my back pressure will also reduce? Valve तो हमने छेड़ा नहीं है, right? We have not touched the back pressure valve. Do you agree?
Yes, sir.
Okay. So if back pressure is reducing, what was happening? Interface will shift
Inwards.
inwards. Is it understood to everyone? How my feed is depicting my, position of my this thing interface? Bolo.
यस सर अंडरस्टूड सर
Yeah.
यस सर सर
बोलो
वो
बोलो.
बाईपास वाल्व का एक बार फिर से वो फंक्शन बताएंगे वो कैसे बताया फिर से एक बार
Bypass
बता दीजिए
valve will create a minimum back pressure onto the system so that fuel gets enough time to remove
सर
the
बाईपास
sludge
वाला और
and
बैक
water.
प्रेशर वाल्व दोनों सेम है
बैक प्रेशर वॉल के बारे में बात कर रहा हूँ. bypass wall is different. Okay, now your fuel when
नहीं मैं
comes,
बाईपास का पूछ रहा हूँ सर
when fuel comes, you have normally, now you all might have done only auto purifiers. Okay, so on the inlet line you have a feed inlet valve and there will be a bypass valve and there will be one recirculation valve. Now what kind of pump it is, your this thing, your feed pump? Feed
गियर
pump कौन
पंप
सा रहता है? Gear pump, right?
अटैच्ड गियर पंप था
Okay, no problem, attached gear pump. So let us say a separate gear pump is there. Okay, a separate gear pump is there.
ओके सर
So am I allowed to close any valve after the gear valve, gear pump?
रीसर्कुलेशन सर
No,
शुड बी
after
क्लोज
gear
बाईपास
pump,
शुड बी
any
क्लोज
gear pump, am I allowed to throttle the discharge of the gear pump?
No, sir.
In
No,
in
sir.
centrifugal pumps, we are doing this throttling of the discharge, right? But in gear pump, never ever we are going to, what do you say, throttle the discharge valve. Agreed? This much is agreed?
यस सर
Okay.
यहाँ सर
So suppose this is the line which is now going to your purifier feed inlet. Okay, feed inlet. This is purifier. Okay. Now, when I'm going to tell you later on manual how to desludge and all those things. That time you will understand again about this concept. Now, normally, when my purifier is running, feed inlet is completely open. Okay, recirculation is completely shut. Okay, and by the bypass valve opening, I can adjust how much fuel can go back and recirculate here. Okay.
ओके सर
Okay. इसमें एक वॉल बॉटल बनाना है.
बेसिकली वी आर कंट्रोलिंग द क्वांटिटी एंड द प्रेशर
Yes,
आई कैन से
quantity is feed आपको change करना, right? So if I
यस सर
want to increase more feed, I will close the bypass valve. It will go more fuel
यस
will
सर
go from here. If I want to
यस
reduce
सर
the fuel going to my feed, I will open the bypass valve. Agreed. It is a
So
little
to
bit
increase the
complicated
feed, we are
line.
using bypass valve.
इंक्रीज में सर क्लोज होगा
what increase में close होगा, right?
इंक्रीज.
Okay.
हाँ यस सर.
So if you're closing it, this bypass wall, you're increasing more feed from the inlet, feed inlet.
यस सर. यस सर.
Okay.
यस सर.
So now what is going to
सर
happen is, yes,
so his pressure is also being controlled by bypass valve.
just give me a minute.
Okay sir. Okay.
भाई ये बाईपास वॉल्व नॉन एनआरबी है क्या?
So what
हाँ
I was
होना तो
saying is,
चाहिए. और
by controlling the bypass wall, you are going to, adjust the feed. Okay. And this
क्यों सर?
recirculation valve will be opened once your purifier, desludging time will come. What will happen? What you are doing is you will open the recirculation valve. Obviously, right now, all are auto. So this recirculation valve will open first and your feed inlet will close. So oil will recirculate here. And this line is also going back. One line is also going back to tank also. Okay. So oil is getting recirculated within the settling tank. I don't want to give any feed at that point, right? थोड़ी देर बैठा मैं अन्ना थोड़ी देर ना 7 बजे होनी क्लास का. Did you understand what I say?
Yes, sir.
Okay. So this is a function of a
सर एक
bypass
डाउट था.
recirculation. Yes.
सर ये बाईपास वॉल्व एनआरबी है क्या?
What?
ये
Yes, yes,
बाईपास वॉल्व
yes,
एनआरबी है क्या? नॉन
yes,
रिटर्न वॉल्व.
yes, yes.
ओके.
Okay. So I will just erase this now. Okay. This is a function. I will come to all these things, but little later. Okay. पहले basic concepts I have to do it. Then I will go for, how the purifier is getting started, how purifier is getting stopped, how it is desludging. I will tell you all manual steps. Now, for auto, it will be solenoid operated, right? वहीं पे line पे, if I put a solenoid, it will be opening my valves in auto, in according to the timer. Agreed? Is it clear? Now I forgot what I was mentioning before. What was the last thing that we did about this
Back
diagram?
pressure valve. Back pressure valve.
Back pressure valve.
Back pressure.
How the feed inlet and how the back pressure valves are depicting your interface, right? This is what we discussed. Agreed? So
Yes,
let
sir.
me just write down something over here. Okay. So interface, ऐसे याद ज़्यादा अच्छे से रहेगा आपको. Interface shift outward. Okay, Abhishek, give me one reason interface will shift outward. One reason.
Gravity is big, sir.
Okay.
The gravity disk.
Wait. I will ask one more. The gravity disk too large. Anurag, tell me one thing.
Yes, sir.
एक चीज और
Sir,
बोलो.
feed is less, sir. Feed
Feed
less, है,
is
sir. So
so
less,
I
sir.
can say flow rate
Is less, sir.
less. It will go outward.
No, sir, it will come inward.
नहीं, अंदर आ जाएगा सर, क्योंकि प्रेशर
Flow
नहीं
rate
मेंटेन होगा ना सर.
flow rate
More
increases,
feed.
right?
Yes, sir.
Increases. Because if I increase the flow rate, my back pressure wall is still at 1.5 bar. So I have given more fuel now. When now it is still close only at that punch point, right? So it will create more back pressure onto the system and the interface will shift outward, right?
Yes, sir.
सर
Okay.
सर
Yes.
जब ग्रेविटी का साइज लार्ज होगा तो इंटरफेस आउटवर्ड कैसे शिफ्ट होगा?
Okay. Hold it. Hold on. Suppose this is my gravity disk. Okay. And this is the top disk. Okay. And suppose this is the pipe and all these things. Okay. Now this is my gravity disk. So this diameter if I'm going to increase the size, right now my interface is obtaining over here, right, between the top disk and my disk stacks. Agreed? This is the interface. समझ आ रहा है what I'm drawing? I'm
Yes,
just
sir.
drawing a rough diagram. Okay, interface. Okay, this is the gravity disk, suppose. So this area is right now less. Okay, less amount of water can go out at this moment. Okay, but if I'm going to use a large gravity disk, that means the diameter I'm going to increase. Now I have much more diameter. My more amount of water can flow out. If water is flowing out, what will happen to this interface? It will shift outward, no?
Yes, sir.
Consider as like a back pressure valve. Okay, consider as like a back pressure valve. If I am going to not let water go, my interface will shift inward. If I let water go too much, the interface will shift outward. Agreed?
So
नहीं
higher
समझ आ रहा?
temperature can affect the interface.
Yes. So flow rate increases your interface. Is it understood? Outward कैसे हुआ? Keshav, you are the
क्योंकि वो फ्लो
AC.
रेट ज्यादा आ रहा है और बैक प्रेशर भी क्रिएट हो रहा है, तो वो उसको बाहर शिफ्ट कर देगा ऐसा।
सर सीलिंग वाटर और जो ऑपरेटिंग वाटर है उसकी वजह से भी हो सकता है क्या सर ये?
No.
नहीं।
Okay. Now next thing is specific gravity of or density increases. ये डिस्कस किया था बैलेंस इक्वेशन में. We discussed about this in balance equation, right?
हाँ सर, जिसमें डायमीटर डिक्रीज करेंगे बैलेंस
So
करने के लिए।
yes, next is viscosity
विस्कोसिटी
increases. If viscosity increases, again separation will not be very proper, and your this thing is going to shift outward. Next is temperature. If viscosity is higher, that means temperature will be
हायर, लो
low.
लो
Low.
लो।
लो सर लो।
Okay, and whatever the opposite of it, you can write it over here. Gravity disk size too small, flow rate decreases, specific gravity or density increases, oh sorry, decreases, then viscosity reduces, and temperature if too much temperature also you give, the shift will be inward. Okay, and if shift inwards, then water will start coming. That's why we are maintaining order around 95. उससे ऊपर नहीं जाते. ठीक है? 98 also you can go. It has gone above 100 also. ठीक है? Nothing much happens, but normally it should be maintained around 95 to 98 for HFO, and for your lube oil purifiers you are maintaining around 90 to 95, right? So is this much clear, guys? Everyone, bolo. Is this much clear?
सर ये होल सर ये
Yes, sir.
डिस्क का जो होल्स है, इज दैट बिग इनफ दैट एचएफओ पास हो जाता है सर इन इस होल से?
Yes, you can put your finger inside. इतना तो रहता ही है. ठीक है? It is big
ये
enough.
डिस्क होल सर?
Yes. You are talking about these holes, right? These holes, isn't it?
यस सर।
Yeah, it is big enough. You can put your fingers also. Okay, at least the smallest finger
सर
you
इट
can put.
डिपेंड ऑन द सर लाइक मैन्युफैक्चरर आल्सो,
What thing?
जैसे
Depends upon
जो
kitna, how much big your purifier is, how much oil it is going to, carry and all. So it will depend upon all those factors. Okay, is it clear? Back pressure and how my, the interface, what is interface, where it is maintaining, how this interface
सर वो
can move
इनवर्ट वाला
inward,
लिखना है सर।
how the
सर
interface is
एक चीज,
moving inward and outward, and regarding how my overflow is going to happen. See, this is overflow only, right? All these things
यस
are
सर।
overflow, right? Okay. I'll
तो ये
just move
टेम्परेचर
forward.
के
सर
बारे में एक बार बता दो।
What temperature?
सर
Temperature
ये
decrease होगा, viscosity increase हो जाएगी. Viscosity increase होगी, then the separation will be very poor. The water content is not going over here. Agreed? So what will happen?
सर
Oil,
सर ओवरफ्लो वाले केस में सर ये इंटरफेस जब शिफ्ट करेगा आउटवर्ड की तरफ तब होगा ओवरफ्लो।
बोथ वेज।
both ways, ना?
बहुत
Okay.
बड़ी।
If यहाँ से if outward जा रहा है, then oil will go from the water side. If it is inward, then water is going from the oil side,
ऑयल साइड।
right?
सर तो ये बैक प्रेशर वॉल का काम बस यही होता है, इंटरफेस मेंटेन करना क्या?
Not just back pressure valve. Calm interface is for specifically, if somebody says specifically, it is for the gravity disk, right? It maintains the interface. Agreed.
हाँ जी, हाँ
But
जी।
the
लाइक
back pressure valve will, the name क्या है? Name क्या है इसका? Valve का? Back pressure.
बैक प्रेशर विल क्रिएट अ बैक प्रेशर इन द लाइन।
You create the back pressure in the purifier. Why? Because you do not want pump की तरह act नहीं करना चाहिए ना. This should not act as a pump that it will just give, what do you say, flow directly without separation. You want some time also. Agreed? You need some time for
यस सर,
separation, na? For that particle to be
यस सर।
thrown outward, you need some time, and that is what it is supplying that time. 8,000 RPM. If you don't open complete back pressure valve, it will not even separate anything. Agreed? It is not going to separate
ओके
anything.
ओके सर।
Yeah, you need some time for oil to stay inside and, you know, throw the heavier particle outside. Okay. Can I move forward, guys?
As it allows time for proper separation, so then only it can go out.
Yes, you can say that.
Okay.
Can I move forward?
Sir,
Yeah.
hello, sir.
Yeah,
Sir,
yeah,
is
Bolo.
this back pressure valve? Sir, is this back pressure valve is in the same line of the outlet of the oil? Both
Yes,
back pressure
outlet में
valve
रहता है
and
ना.
discharge.
You are adjusting on board these valves, right? On the outlet part, these valves are provided. Okay, यहाँ पे मेरे
Sir,
को I don't have.
is this
Hold on. This will work now. Thank you for this, Chirag. हाँ? कोई, is there any purifier photo with assembled one like this? Not in this one. See, this is Mitsubishi, right?
Yes, sir.
Yes, sir.
Okay, can you see there's a valve over here, right? If you see in your manual, na, if you open this valve, it will work as a clarifier. Okay. Okay. Now in this line, actually one will be inlet and one will be outlet. At the outlet part, you will be having a valve, right?
विच वॉल्व सर?
यहाँ पे एक है valve, right? दिख रहा है आपको ये line? This line is, and valve is I think broken or something. Okay, this is a non-return valve and this is a normal valve. Okay, so this is open to make it a clarifier. So nothing you have to do in this type of purifier. Okay, so there is a back pressure valve. Okay, it is not visible at this moment. यहाँ पे एक valve रहेगा नीचे की तरफ, right? Which we are adjusting to increase this back pressure. It is right now this much, right? 1.4542. This is my back pressure at the moment. This is the feed. Agreed. So on the return line, on the outlet line of the purifier, one valve is present. Okay, and that you have to throttle to maintain the back pressure, and you can see the back pressure over here. If somebody has a better diagram, you can show me. I'll tell you. Okay. Or wait, I'll be having it here.
Excuse me, sir.
Follow.
Excuse me, sir.
Tell me.
सर मैंने अभी कुछ देर पहले एक डाउट पूछा था. एक्चुअली मुझे डाउट ये था कि सर आपने बताया था कि जो ग्रेविटी डिस्क का साइज है, अगर उसको बड़ा करेंगे तो इंटरफेस हमारा आउटवर्ड शिफ्ट होगा. तो सर लेकिन इसमें मुझे डाउट है सर. इसमें अभी तक जो मैंने पढ़ा है उसमें जो ग्रेविटी का साइज है उसको अगर बड़ा करते हैं तो इंटरफेस सेंटर की तरफ मूव करता है.
ऐसा है क्या?
जो लास्ट सर जो संतोष सर ने बताया था वो भी ऐसा ही बताया था, और इंटरनेट पर भी चेक किया तो वहां भी यही चीज है मेंशन किया है.
भेजो
आपने जो
भेजो
लिखा है ना डिफरेंस.
भेजो मैं.
ओके सर.
In what context they are saying it, that also has to be understood, right?
केशर,
हाँ भाई.
हम लोग लास्ट टाइम अंकुर सर के क्लास में थे, वो भी यही बोले थे कि इफ ग्रेविटी डिस्क इज बिगर, इंटरफेस विल गो आउटवर्ड्स एंड बैक प्रेशर विल डिक्रीज.
नहीं भाई, मुझे भी याद है सर ने बताया था ऐसे ही कि अगर इनवर्सली प्रोपोर्शन होता है, अगर साइज बड़ा करते हो तो वो अंदर शिफ्ट होगा, अगर साइज छोटा करोगे तो वो बाहर की तरफ शिफ्ट होगा। और जो मैंने
Okay,
अभी
wait.
स्क्रीनशॉट भेजा वहां भी।
Okay, wait. Now you see here, one is the inlet part and one is the outlet line. Can you see there's a valve over here present in this outlet line? This is the outlet, okay? Can you see there's a valve here? Okay.
Yes, sir.
If you adjust this valve, then a back pressure will be created onto the system and fuel will stay for a longer period of time inside the purifier for separation. Clear? है? Is it clear?
ये सर।
Yes, sir.
Okay. All right. Okay, as far as I'm concerned, Keshav, what I've said is absolutely right from my side. Okay, but I will still check it. Maybe I might be wrong in somewhat. Okay, I will still check what you're saying. Okay, you are saying if
सर
the
मैंने ग्रुप
gravity
में
disk
देखी।
size is increased, you're saying if the gravity disk
ये सर।
size is increased, then that means the diameter has increased, then the interface move inward. This is what you're saying, right?
ये सर, और इस फिगर के
So,
अकॉर्डिंग जो आप बता रहे हो, यहाँ
okay,
पे ग्रेविटी
hold
का
on.
साइड का लोकेशन शायद डिफरेंट है।
Hold. You answer it now. Suppose this is the gravity disk. Okay, this is my gravity disk. Now, if I have to reduce the increase the diameter too large, that means half कर दूं मैं, चलेगा? Only this much is my
नहीं
gravity
नहीं
disk.
सर, एक्चुअली मुझे यहीं से डाउट हुआ था, ये जो लोकेशन है ग्रेविटी का साइज, ग्रेविटी का लोकेशन, ये आई थिंक यहाँ पे नहीं, थोड़ा और अंदर में रहेगा शाफ्ट के अंदर नियर।
I'll show you the manual diagram here. ठीक है? Hold on.
ये सर एक बार आप वहां से एक बार चेक करो।
ये लो. This is my gravity disk. Now you tell me. If I increase the diameter, that means इतना ही है gravity disk. Suppose, okay, only this much is gravity disk. Now this diameter has increased or not? Or the radius, at least the radius has increased, that means diameter also has increased, right? If this much is
यस सर।
my, so more amount of air, or sorry, not air, your water can go out.
यस सर।
Okay, if more amount of water can go out, where will the interface shift? Will it shift outward or inward?
आउटवर्ड सर।
It should fit outward ना. This is the manual diagram. अभी इससे तो कुछ नहीं हो सकता ना. फिर भी I will check it. ठीक है? If you still have doubt or
ओके
maybe
सर।
could be wrong. Okay. If और एक बार
नहीं सर, अभी
दोबारा
चेक
देखो.
किया, आप ठीक बता रहे हैं मुझे।
ठीक है, you can check one more time what actually संतोष sir has said और ठीक है, एक बार दोबारा चेक करो. मे बी कभी एक बार फ्लो में ना somebody want to say something and मेरे से भी होता है कई बार, right? Want to say something but निकल कुछ और जाता है, isn't it? So that could be there, but as far I know this is what it is. ठीक है, and I can prove this with diagrams also with this thing. All right, can I move forward a little bit, guys?
Yes, sir.
Yes, sir.
Yeah, okay. Ankur said, sir only also said the same thing actually, right?
हाँ सर, सेम
Yes,
चीज,
sir.
स्क्रीनशॉट भी है मेरे पास।
Same thing as me or what Keshav is saying?
नहीं
Same
सर,
as you, sir.
जो आपने कहा था।
Okay. So let us
Sir,
discuss
larger
now.
dia oil will overflow. So what you're saying is correct, sir.
Okay. So let us take a purifier discs, okay, like this as a disc rather, right? So let me take 1, 2 discs over here, and this is what is this,
और
Mohit?
अंकुर सर ने जो पढ़ाया था ना, उसमें लिखा हुआ है, स्टेटमेंट भी लिखा हुआ है, और वो डायग्राम थे बनाए हुए हैं उसने।
Okay. Alright, so
तो दोनों आपका उनका सर का सेम स्टेटमेंट है।
सर मेरे पुराने नोट्स में भी यही लिखा है।
all right,
If
don't.
gravity disk size increases.
Now suppose from my what do you say distributor, the oil comes, okay, and it is exactly here in this part. Okay, suppose this is one of the solid or water impurities. Okay, this black color portion is solid or what do you say water impurity. Okay, so what is going to happen over here? What all the forces that are acting on this at this point?
So gravitational.
Sir, centrifugal force and
सेंट्रीफ्यूगल
throughput
फोर्स
will be
ज्यादा
acting.
So this will be throughput.
Yes, sir.
Agreed?
यस सर,
There will be one centrifugal force.
यस सर,
Agreed? There will be one resultant force also.
यस सर,
So the resultant force, what action is going to happen onto this molecule, which is heavier as compared to the oil, it will be thrown away with the resultant force angle. Okay, जो resultant force का angle है, same angle, this will be thrown outside, and it will start accumulating at the periphery. Agreed?
यस सर,
Yes, sir.
This angle will depict your what will be the angle of your purifier plates between the throughput and your, when you will make a centric diagram na, like this, suppose one plate is there and your oil particle is exactly at the point where oil is entering. So यहाँ से नीचे से throughput force लग रहा है. This is throughput ना, inlet. Agreed?
यस सर,
Oil inlet. So this force is acting like this. This is my throughput. There is one centrifugal force which is acting like this. So on both, if I join, that will be the resultant force.
यस सर,
So this angle will depict what angle your purifier plates will be. Is it clear? Purifier plates ऐसा नहीं है ना?
Yes, sir.
ऐसे नहीं है. Agreed? Neither it is straight. It is at certain angle down below, isn't it? As a cone. So what is that thing that is depicting at what angle I should keep it? That will depend upon the resultant force. Is it clear? And the
यस सर,
heavier particle will be thrown outwards in that resultant force part. Is it clear? Bolo guys, is it clear? This much?
यस सर,
Now, suppose the oil moves little bit forward. Doesn't mean that all the what you say, heavier particles will be pushed from here itself. Heavier particle might have reached here,
यस सर,
right? At here, does my throughput is acting?
नो सर,
There's no throughput here, right? Now I'll be having a flow of the fuel,
यस
force of
सर,
the flow, right? Now oil is going up now, clean oil, isn't it?
यस सर, यस,
This debris, or what I can say, water molecule or my sludge, what all force are acting here also? Is the centrifugal force acting?
नो सर, सेंट्रीपिटल एक्ट करेगा ना सर,
Centrifugal force is not acting.
सर करेगा
Purifier is running at
करेगा सर
करेगा
10,000 RPM.
everywhere.
Yes, sir.
Centrifugal force is acting, isn't it?
Yes, sir.
Force of flow. Okay. Now this throughput is not there. Now I have a centrifugal force also. It is always, what do you say, horizontal, right? Outward. Horizontally outward रहता है ना centrifugal force.
Yes, sir. Radially outward. Yes, sir.
Yeah. So the resultant force will be like this. So that means this molecule will be thrown onto the plate. Once it is thrown onto this plate, here the velocity of this fluid or water or your sludge, okay, will become zero. Velocity zero हो जाएगा.
यस सर,
Okay, the velocity is going to be zero. It will be thrown towards your this thing because of the resultant. This is the resultant force in this part. Okay, and it will be thrown on to your disc's top. Okay, and from there this will roll down and accumulate because of the centrifugal force. It will accumulate on the periphery now because the velocity is gone from it. It will be rolling down and it will be coming down to the periphery of the plate. Is it clear?
सर ये फोर्स ऑफ फ्लो भी सेंट्रीफ्यूगल और इधर वाला भी सेंट्रीफ्यूगल है क्या? वो दोनों तरफ लग रहा है?
No, this oil will that is centripetal. ठीक है, that is centripetal. It is going
फोर्स
inside,
ऑफ
but
फ्लो ना सर,
हाँ, force of flow is a centripetal force
हाँ
only. Okay,
हाँ हाँ हाँ,
but
yes sir, yes sir, that's what.
but but a centrifugal force is acting here, okay, outward, and this is the force of
Yes
flow
sir.
normally बोलते हैं, and this is actually centripetal force. Okay, it is because going
हाँ
inward.
जी वही.
Okay,
हाँ
lighter
जी.
particles will always be going inward. Okay, that is centripetal force,
Yes
and
sir.
this is my resultant force. Okay, so resultant force, I told you in the previous part also, the resultant force will depict where your molecule will be thrown.
Yes sir.
Okay, so through this resultant force, this molecule is going to hit on the periphery of my plate, on the bottom side of my plate. Sorry. And once it hit on the plate, the velocity of that molecule is become zero. Velocity zero हो जाएगा.
Yes sir.
Yeah. And once the velocity becomes zero, now it is obviously rotating at a very high RPM also. So this velocity has become zero. It will be thrown outward plates के साथ साथ. Okay, from to along to the surface of the plate, it will be thrown outward, and it is happening everywhere, not just on these part. Okay, not just on this part. It is happening here also, everywhere it is happening. Okay, so it is able to, but at the center part, I've told you what will the resultant, right? When it is, because यहाँ पे throughput is acting, isn't it?
Throughput.
At this
Yes
point,
sir.
the throughput is acting here, right? Here the throughput is acting, but other places the throughput is not acting, and there the vector diagram will become different. Okay, what did Ankur sir and Santosh sir told about this?
So same thing.
Yeah, same thing, right? Okay.
Sir.
So this will depict how your construction
Sir,
of your.
after this,
बोलो बोलो.
sorry to bother, sir. After this, the velocity will get zero, sir. So that means the centrifugal is more force is more than the centripetal force. That is what it is driving the matlab sludge to periphery. Is it what, sir?
नहीं.
No. I'm not talking about that. Okay, I'm talking जो आपका molecule का velocity, sorry, the velocity. I'm talking about the velocity of this molecule when it is going to hit on the periphery. It will become zero. I'm not talking about centripetal force. I'm not talking about centrifugal force. I'm talking about the velocity. Okay, the
मतलब सर
velocity.
उन दोनों का जो रिजल्ट.
Yes, the resultant will depict where this molecule will be thrown. Okay, in this part,
Okay.
I have told you when it was in here at this point when throughput was acting. So this is throughput, this is centrifugal force. Now it will be, this will be the resultant. But now when it reaches over here, now no longer my throughput is acting. Agreed?
हाँ जी, हाँ जी.
So I only have the centripetal force which is pushing it inward, the clean oil. Agreed?
And
And
centrifugal which is acting
I
outward.
have a centrifugal force which is pushing heavier particle outside, but it will flow towards the resultant. Okay, and the resultant force,
Okay.
resultant is the one where this molecule will be thrown, and the velocity will come zero when it will hit on your bottom side of the plate, and it will be rolling down from the top side, and it will be accumulating on the periphery of my bowl. Is it clear?
Okay, sir. Okay, sir.
So this is what is happening here. Okay, and your sludge will be accumulated over here. Whatever water content is there, it will be at this part. Sludge will be at this part. I have told you before itself with that example, right? बोला था. Here sludge, water,
Yes,
then
sir. Sludge,
oil,
water,
okay, then
and oil.
again water and sludge,
Then
isn't it?
water and oil.
Only oil
Yes,
is
sir.
in center part. Okay, this is oil. Rest is water, both side, and on the both side again sludge. So is this much clear?
Yes, sir.
Yes, sir. Clear.
Okay. So we will stop here for today. Okay, and we'll discuss tomorrow regarding. थोड़ा बहुत I'll go deep. But if it is taken so nicely, then why you wanted again to take it?
सर स्ट्रोक टू बोर रेशियो पढ़ा दीजिए सर.
I have to go, yeah, actually somebody has come, huh? So I will take it tomorrow. चलेगा?
सर तो ये पूछना था सर कि ये फंक्शन 4B के जो टॉपिक्स है सर वो थोड़ा कवर कर लेते इस मंथ में एग्जाम